Hello everyone. Last time we had a brief touch on the properties. We mentioned that a class or a struct can have some properties to store their data. Today we'll explore more into this topic. We'll explore different kinds of properties. Here we have a class called data, and data has a property called file name. This property is a regular property, and it will be initialized to data.txt when an object of data is instantiated. Now we have a different kind of property. It's called lazy property. And we have a biggie as a lazy property. It's denoted with the keyword lazy. A lazy property is a property that will not be initialized at the time that object is created. It will only be initialized when this property is accessed. For example, we create a d equal to data. So here we created an object of data and assigned to d. And at this time, this property file name is initialized to data.txt. However, this another property biggie, which is a lazy property, is not initialized. It's still nil. And then we access this property biggie, and biggie is initialized to a long array, and now this biggie is no longer a nil. A lazy property is useful when its value cannot be determined at the time of initialization, or the calculating of its value is computationally expensive or involves a lot of IOs, so that at the time of creating the object, you don't want to initialize this particular property. You want to initialize it when you use it, because there's still a big chance that this property will never be used at all. Then the time and effort of initializing it can be saved. One thing to point out is that global variables are always lazy. So they are not initialized at the time your program starts. They are only initialized when they are accessed. And all the local variables are always not lazy. Now let's look at a different kind of property. It's called computed property. A computed property is a property that doesn't have a storage. Its value is computed on the fly when you access the property. For example, here we have an area which is a computed property. And when you access area, the function get will be called, and its value will be computed in the fly with other properties. And when you set the area to a new value, the set function will be called with a new value. And the other property height is updated based on the new value of the area. So this is a computed property. And correspondingly, these properties are called stored properties. And if you want to make your program more concise, you don't have to specify the parameter of the setter function. You can use the default parameter of new value. For example, if we delete this parameter, we can use the default parameter called new value. And if my computed property doesn't have a setter function, it only has a getter function, then this computed property is a read-only property. But the opposite is not true. The computed property cannot have only a setter function and not having a getter function. Now let's talk about property observers. Property observers are two functions that are called when the value of a property is changed. For example, the height property has two property observers, willSet and didSet. The function willSet will be called before the value is set, and the function didSet will be called after the value is set. The willSet function takes a parameter of the new value, and optionally you can use the default parameter of new value. And the didSet function takes a parameter of the old value, or you can use the default parameter of the old value. One thing to note is that if you access the value of height in the willSet function, the height has the old value. But when you access the height in the didSet function, the height has the new value. Here is an example of using the observers. let r equal to lect 3, then we set r dot height equal to 4. And right before the height value is set to 4, the will set function is called. And right after the value is set to 4, the did set function is called. Not every property can have observers. If a property is a lazy property, it cannot have observers. If a property already has a getter or setter, it cannot have observers. This is because if a property has a setter, you can specify the observation in the setter. If a property doesn't have a setter and only has a getter, that means the property is read-only and it cannot be changed, so there's no reason to observe its changes. Next thing we want to talk about is the type properties. Type properties is just like the static properties in other languages. For example, here our structure rect5 has a type property which is called color, and the type property is denoted with the keyword static. And a type property is a property that is shared by all instances of this type. And when you access them, you need to access them through the type name. For example, rect5.color will return the value of the color white. Rect5.color equal to black, we are changing the color to black. Similarly, a class can also have type property, but a class's type property is denoted with the keyword class. In this version of Xcode, this feature is still not supported. We have talked about a lot of properties for structures and classes, but there's one thing that we haven't talked about is that an enumeration can also have properties. But an enumeration can only have type properties and computed properties. It cannot have stored properties. For example, the enumeration of direction has a type property of P1 and a computed property of P3. And we can access P1 through the type name and access P3 through an instance of the enumeration. However, you cannot have a property like P2 because P2 is a stored property. Thank you for watching. Feel free to download the notes from my website and practice with it. See you next time.